A while back, I was working on this Python project, and like always, I got stuck in the classic loop. Pip install this, poetry that, venv here, requirements.txt there, and you know the drill. I felt like I was spending more time juggling package managers than actually writing code. And then I stumbled across something new, something that promised to be faster, cleaner, and way less painful. It's called UV, and honestly, it might be just the best package manager Python has been waiting for. And whether you're using Windows, Linux, or macOS, you have to copy one of the installation commands and paste it in your terminal or command prompt. We simply hit enter and we're done. After installing UV on your machine, the next step would be to check whether you had installed any version of Python on your system. For this, we just type Python version and we see that we have Python version 3.12.1. So now I type the command uv python install and a specific version of Python that I want to install. As simple as that, I installed a new version of Python. Now I check whether I have Python 3.11 installed on my machine. It returns the path to the 3.11 version. What about 3.12? Note that the version 3.12 is not installed by UV. It was bundled by OS by default. Let me check a couple of other versions of Python to see whether they are installed by UV on my machine. You have to get comfortable with the debugging commands uv python find and uv python install to be able to solve the problems that you face about the missing versions of Python and incompatibilities. Nice, Python version 3.13 is installed and ready to go. Just to be sure, I check where the version 3.13 is located at. So we have several versions of Python installed. How to run our script with a specific version of Python? For that, we use uv.run command, passing the Python version and the name of the script. Just to make sure everything is working as expected, let me import the sys module and check the version of the Python that I'm running the script with. So we know that the uv command is working as expected, using the specific version of Python for running the script. Here I don't pass the name of the script on purpose. Let's see what happens. You see that it returns a message saying that you have to run the command uv.run and pass the name of the script.py. So let me rerun the command and pass the name of the script and see what happens. Nice, running the code with the interpreter version 3.11.13. What about 3.13? Again, I see the 3.13.7. Nice. So the uv.run command and passing the version of Python is working as expected and running the specific version of Python that I have specified. So the next obvious question would be, how do we add a third-party package to our Python code? For instance, I import requests module, and for this I use the requests.get and get the web page, for example, google.com. Let's print the response object just to make sure everything is working as expected. So the module is not found. How do we add this module and run our script successfully? The solution is to pass the --with option with the name of our package. Here it is requests package. If you have noticed, the number of options we are passing to the uv.run command is increasing. How can we pass all of these options without passing them from the terminal? We can do it somehow in the part of the script. Let me show you. For this, we simply use uv init and pass the name of the script and the options that we want to. What options had we passed before? One of them was Python version. You see a comment version added at the top of the script. uv.run will use that comment to get the specific information that it wants. You remember this error, right? How do we fix it? To fix it, we have to use the almighty uv add command and pass the name of our script and the package that we want to add to our script. In this example, the requests package. The message tells us that the main.py is updated, and the requests package is added to the dependencies section of the comment section. So now let me show you what can go wrong over here. You see that requires -python at the top of the script? If I change it to == 3.11 and run the script, we'll get a surprising result. It says that no interpreter found for exact version 3.11. The question is, what's wrong? Let me check with uv python find command. Well, it seems that it found the interpreter version 3.11. This is confusing. What's wrong? We've got it installed on our machine. The problem is we haven't specified the exact version. 3.11.13 is the version of Python installed on our machine. If you have watched till now, congratulations. A few more steps are required to master the UV package manager tool. I've shown you the example with a simple package. That is a requests package. What about a more complicated package, like PyTorch? For this example, I use uv add -- script, the name of the script, and add the name of the package torch. It gets added to the dependencies section in the comment section at the top of the script. What if I want to remove that package? I just have to use uv remove instead of add. And as simple as that, I can add and remove packages without passing them as options, but rather as a comment section at the top of the script. Till now, we learned how to run a single script using uv run command. But how to initialize a project? For that, we use uv init command. Couple of files get created. One of them is .python-version for specifying the version of Python for the project. The other one is pyproject.toml. Pyproject.toml contains the necessary information for our project. That is the name of the project, version, dependencies, Python version required, and the description, which are essential for any project. When I run a project and add a package, there is a main difference. For example, if I add a package using uv add command, here the requests package, you see that another folder gets created called venv. And that is the virtual environment that Python uses to add the necessary packages. Also, another file named uv.lock gets created, which contains the exact version of the packages that are installed in our environment. This is an essential file if we want to reproduce the exact environment that we are using to run our project. Now that we have our virtual environment, let me install the extensions necessary for running Python in the VS Code using the virtual environment that is set up by uv. Also, do not forget to like this video, which gives this video a boost, and subscribe to the channel to not lose future content. So now I select the venv environment created by uv for our project. This environment contains all the necessary packages installed by uv. So by selecting the environment, every time we open up the terminal, the extension helps us to not run the necessary commands outside the environment of our project. For instance, I add the PyTorch package and see whether it gets installed successfully. To get more comfortable, let's add another package. Let's say something related to scientific computing. NumPy package would be good. So I import NumPy as np and just print the version of the NumPy that I'm using in the project, and then add the NumPy using uv add to the project. Now I have to run this script. For this, I can use the terminal or use the button to run the Python script inside the environment, using the Python extension that I've already installed. We can also use another useful command, uvsync, which synchronizes the packages added to our environment and adds it to uv.lock, so we have the exact version of the packages. And there is a command uv.lock which creates the uv.lock file for our project. Also, I've got to tell you that you can use the same old pip install inside UV. All you have to do is just use the UV pip install and the name of your package. I don't know why you want to do that anymore.